Hey guys, we're gonna do something a little different today. What I have here is an FPV mini drone. So I built one of these and I crashed one of these. So we're here and I'm gonna repair this, and I thought, well, let's show you guys how to repair a drone. So first thing is to figure out what is wrong with the drone. And for that, let's go ahead and connect our drone to a USB cable. Now notice that I don't have any battery connected to my drone, and you shouldn't either when you're performing any of this. And even if you do have your battery connected, you should have your props taken off. So once you connect the USB, you should hear 5 beeps. But we don't hear 5 beeps, and there are no lights going on our actual microcontroller. What you should normally have is a red light and a blue light, and also light on your receiver, which is working. That means that the USB power is going to the microcontroller and it's going to the receiver. Now there could be a couple of things wrong here, and before we start getting all panicked, we should measure a couple of things just to make sure that we are repairing the right thing. Now I have the schematics from a VESC, and luckily the VESC uses the same STM microcontroller as most drones, which is the STM F4. So what I'm looking at is something like this, which is the STM32 chips data pinout. And if you're using an F4 controller, this should be the same for you. What we're looking at here is we are looking at the VDD pin and the VSS pin. So the VDD is your 3-volt pin and your VSS would be the ground. So if you can see here, there's a VDD here, here, and here. And there's a VSS right next to this and right next to this. So what we're going to do right away is we're going to go ahead and measure voltages on these pins, and we should get either 5 volt or 3 volt on VDD and ground on VSS. So let's locate the pins first. So the way to locate these pins is that you see this little circle here, and there's also this little circle on the microcontroller itself. I don't know if you can see it. And the first pin would be on the left side of the circle when your circle is on the top left, just like it is now. So pin 1 would be this pin. So if you go back to our diagram, this is our first pin and our circle should be here, right? So VDD and VSS should be the pins on top. So let's measure VDD and VSS. So I've set my voltmeter to voltage, and very carefully I'm going to measure the VDD pin with respect to ground. Now you have to be extremely careful doing this because the pins are very close together and your scope's probes are really fat compared to the microcontroller. So what you're going to end up doing is when you measure one pin, you're going to end up shorting the pin right next to it with that pin, and that would cause a short, and if your STM was good before, now it's dead. So what you're going to do is go really close and come from this side so you don't end up shorting anything. Keep one probe here and one to ground, and you can choose any ground, and instead of going on the same ground, let's use a different ground, for example this guy. And as you can see on the multimeter, we don't get 3 volts, we get 0.16 volts, which is not good. If you did get 3 volts or 5 volts on this one, that means your chip is good, which is good news, which means the most expensive component of your flight controller is not fried. But unfortunately, that doesn't seem to be the case. Now, let's remove power. Now we don't have power, so we don't have to worry about shorting our pins. Let's check the VDD and ground again. Now you can either check these 2 pins or check this with any other ground because all the grounds are internally connected. So let me change my voltmeter to continuity mode, and if there is continuity between any two pins, it gives a beep. And now the battery is almost dead, so it gives a very faint beep. I don't know if you can hear it, but anyway, so VDD and VSS or ground should not be shorted. There should be 3 volts between them. So one pin is on VDD and the other on ground, and sure enough they are shorted. So that means my STM chip is dead. That is how you diagnose your STM chip. And if you don't get a short between these two terminals, VDD and VSS, that means something else is wrong on your controller, and it could be one of these voltage regulators that convert, you know, a battery voltage to 5 volts or 3 volts, or it could be something else, not your flight controller at all. Maybe your receiver isn't working, maybe the light on the receiver isn't going on, but you know, there could be a lot of things, but that is outside the scope of this video. So what we're going to do is repair the STM chip, and for that we need hot air, and that means we have to take our flight controller out of the drone. Now you notice that there's a lot of connectors soldered onto the board, so we would obviously have to remove those. I mean, it might not be necessary if you're doing the job really well, but I don't like the way they're done, so I want to redo them anyway. So this is some of my Amtech flux that I'm using. I like this because I don't have to deal with needles, and I don't have to deal with toothpicks and whatnot. I can just do this needle thingy. So I'm just gonna grab a bunch of tweezers, start applying some heat, just a little bit, not too much, and start removing the wires one by one. Make sure you don't apply too much heat to these nylon screws because they are just gonna melt. Now the big ones. These might take a little bit of time because there's a large surface area, so make sure you transfer your heat properly by contacting as much of your soldering iron to the wire as possible, and don't apply force on the cable because that will just lift off the pad on the flight controller. Yeah, once it's melted, it's gonna come off by itself, so just like that. Okay, so I've taken off the screws, and that's our flight controller. Let's get rid of the big drone. So first thing this thing needs is a good clean. And I forgot to mention that this one is the Omnibus F4 OSD version, and it's a pretty good flight controller. It's got a couple of nice features. It's got built-in OSD. That's really good. So it's not very old. It's not the latest either, but the only problem is that there aren't any manuals or hookup guides online for this version, so I kind of had to figure everything out myself. Okay, so first things first, we are gonna cover everything around our chip in some kapton tape, and a kapton tape is a really nice thing to have if you are doing a lot of SMD soldering. And I know a lot of you are not doing SMD soldering, but I would suggest you get a hot air gun. They're really cheap now, and you know, maybe just practice on some busted chips. And once you are, you know, good at it, you can start repairing your own flight controllers, your own VESCs, all the good stuff. Okay, I've got my kapton tape on all 4 sides. I'm going to bring in my hot air gun, which is a really nice gun, surprisingly. It's I think only $60, and I've been using it pretty carelessly, and it has stood the test of time. Works really well, so I suggest you get this. I have a review on this, you can check that out. I'm gonna heat it up to about 350 Celsius. I think that should be okay. In the meantime, we're gonna go get some flux on our microcontroller. Sorry for my shaky fingers. I swear I don't do drugs. Is that you have your replacement chip ready, and you know, these chips, don't get them from AliExpress or anything. Please get them from a good supplier like LCSC from China, or Mauser, DigiKey, Arrow, all those guys. Look at this, it's beautiful. Look at how many I got, because I keep burning these chips every single time. And these are the same chips that go on the vest as well, so that's good. Now this is how you want to hold your chip, not by the pins but by the sides. So we're gonna keep our replacement chip ready. Okay, so I've got my flight controller ready with solder paste on it. I've got my STM chip ready, got my soldering iron ready, and I've got my tweezers with me. So what are we waiting for? So first, I'm just gonna, you know, go around in circles, make sure that the flight controller heats up a little bit. I don't wanna shock it with too much heat. So go ahead and do that. Just keep your distance. Keep going around in circles. And you can see, you know, the flux kind of sinking in, doing its thing. Let's slowly turn up the heat a little bit. And you get closer, and you can see the flux should start, you know, evaporating now, doing all sorts of crazy stuff. And when most of the flux has evaporated, and you can see those solder pads get really shiny, that's the time you want to bring in your tweezers. Not now. Don't try to, you know, pull it while it's heating, because you're gonna pull off the pads from the flight controller, and your flight controller is gonna be dead. So it looks like it might be okay, so I'm gonna go ahead and pull it a little bit to see if it's coming off, and it seems to be coming off. So I'm gonna go full throttle. Alright, so our chip is off, but there's some things I would like to do. I would like to clean this real quick. I'm just gonna pour some alcohol on it. Use my daughter's old toothbrush. And you gotta do this slowly, okay? If you do it too hard, again, you're gonna lift the pads. Surely gonna lift the pads. Make sure your toothbrush is clean. Okay. And try to go in the direction of the pads. Okay, I think that's good enough. So this is the time to inspect, see if there's any pads lifted. And I can't see anything wrong with the connection, so they are good, which means we can go ahead and solder the new chip. Now, one thing you'd want to remember is that place the chip where the circle is, right? So yeah, now I was going to place it the wrong way, because circle on the chip is here, and on this one it's here. So this is the correct way. So to solder these back on, what I prefer is go with a soldering iron instead of a hot air gun, because it's just easier. And if you do use a hot air gun, you're gonna have solder bridges anyway, and you're gonna use a soldering iron to sort out those bridges, so what's the point of doing it twice? So how are we gonna do this? Get your soldering iron and get a little bit of flux on your soldering iron, not too much, just a little bit. Once you do that, place your chip right where it's supposed to be. Just like right now, I think it's okay. Just hold it down a little bit. Come in with your soldering iron. Get solder on one of the pads. Okay, clean your tip. Hold it down without moving it. Do the same on the other side. Okay, it doesn't matter if there's a solder bridge, that's okay. It seems like our chip is very nicely put in place. Let's inspect it. Yeah, I don't see... Oh, maybe this side is a little bit off its pads. You know what? Let's use a microscope. Alright, so what I'm going to do here is bring in my hot air and try to realign this. Okay, I think I have it properly done. Now what I want to do is get my soldering iron in and really try to spread the solder over. So I'm going to put a little bit of solder on the tip of the iron and just move it along. So I'm going to go ahead and use my microscope now, and the recording function of the microscope stopped working, so you're just going to have to watch this shitty footage of my phone recording my microscope. So let's go to the fourth and final side. Let's put on some flux here, because this really seems very dry. And just try to melt this solder. Don't apply too much pressure. What we're trying to do is redistribute the solder to all the pins. Simple. And clean it using. Let's see how it looks. Looks good. Okay, it seems to me that the job is complete. So again, let's check all four sides to see that there are no shorts and that each pin is soldered down. Okay, I don't see any shorts. I'm going to give it a clean, even though it's no clean flux, so you can leave it as it is. So I forgot to check for continuity while the chip was off, but now we put it back on, but that's okay. So let's go ahead and see if there's continuity between VDD and ground, and there shouldn't be any, because that's what was wrong with the controller. If there is, then we have a problem. So that's VDD, and the first two pins are ground here, so good. I don't see any short. And let's check ground and ground, which is the second pin, and there should be continuity. And yes, there is. Awesome. Okay, so we've had a successful implant. Now when we connect the USB to the computer, we should see some light going on. And sure enough, we have the power signal on, which means it works. We don't have the blue light yet because the STM chip is not programmed. It doesn't know what it's doing, whether it's on a flight controller, on an ESC, what is it doing. So once we do that, put in the bootloader in there and flash it, we should have the blue light as well. But that's for another video. This is already too long, but it worked. We saved a flight controller.